Hello everyone, welcome to the second part of name reactions. I'm Rahul Mahire. Now in this section we are going to study the name reactions. The first one is aldol condensation or aldol reactions. There is difference between the aldol condensation and aldol reaction. We will see in next slides what is the actual difference between the aldol condensation and aldol. First, we have to learn the reactions and after that reaction mechanism. In aldol condensation, the two aldehydes are react with each other in the presence of base and form a beta hydroxyaldehyde that is nothing but the aldol. This reaction is known as aldol condensation reaction. In this reaction, the final product is beta hydroxyaldehyde, that is the aldol. Hence, it is known as aldol condensation. See, this is the alpha, beta, and at the beta position, hydroxy group is there. Hence, it is a beta hydroxyaldehyde. Hence, it is a aldol. Hence, the reaction is known as aldol condensation. Now, in reaction mechanism, we see how the aldol is formed by the mixing of two aldehydes in presence of basic condition. The first step is when one of the aldehyde when reacted with the base it forms an intermediate, that is the carbanion, and this carbanion attacks on the highly electropositive carbonyl carbon, and immediately the negative charge is shifted to the oxygen of another aldehyde. This oxygen is already electronegative, acquires negative charge, immediately picks up the proton from the water molecule which is generated here and form a aldol, right? Now I repeat again the reaction mechanism. In first step, the base is reacted with the aldehyde, moves at acidic proton, that is the alpha hydrogen get abstract by the OH and form a carbanion. Now this carbanion act as nucleophile and attack on the electron deficient carbonyl carbon. By the attacking, the charge is shifted to the oxygen of another aldehyde and this oxygen get negatively charged. Oxygen is already electronegative element, acquires negative charge, hence it immediately abstracts the proton from the water molecule which is generated in the first step and form a beta hydroxyaldehyde, that is nothing but the aldol condensation. From this reaction mechanism, we learn two to three things. The first thing is that the react for the aldol condensation, the alpha hydrogen must be present at the aldehyde. Whatever the carbanion is generated, it acts as a nucleophile, and in the third one, the negatively charged oxygen abstracts the proton from the water molecule, immediately convert into the hydroxyl, and it gives the aldol as a product. So this is the reaction mechanism of aldol condensation. This is another example of aldol condensation. Substituted aldehydes, two different aldehydes are mixed together in presence of sodium methoxide gives the aldol. See, this is the alpha position, this is the beta position, and we get the aldol. Now see in reaction mechanism how it actually happens. In first step, the base abstract the alpha hydrogen atom and negative charge shifted to the oxygen. This oxygen attacks like enolate on the another aldehyde in which negatively charged shifted to the oxygen. We know that carbanion is generated into the aldol condensation we see in the previous mechanism. In this step, you can also see the you can also show that the removal of the hydrogen molecule, this carbon get a negatively charged instead of this one, so this carbanion can attack on this electrophilic carbon of carbonyl. Okay, so there are the different ways to show the reaction mechanism. In previous mechanism we show the formation of carbanium, while in this mechanism we show the direct charge shifted to the oxygen. Okay, now in the next step, whatever the intermediate generate having the negative charge on the oxygen pick up the protons from the generated methanol and form a aldol product. So this is the reaction mechanism, just shown differently than the previous slide, in which we show the carbanium. Here we didn't show the carbanium, but the meaning of that enolate is now. Previously two reactions are the example of aldol reactions. Now we see the condensation product, actual aldol condensation product, in which whatever the aldol is generated by the removal of water molecule in the presence of heat, the water molecule get removed and carbon-carbon double bond is formed here. That is the dehydration process. Hence, we get the alpha-beta unsaturated ketone is a product of aldol condensation. See in the reaction mechanism, we know this is the aldol. In this aldol, the alpha hydrogen get abstracted by the base in such a way that the water molecule or the hydroxyl group can be removed and form a alpha beta unsaturated aldehyde or carbonyl compound. So this is the condensation product, in which alpha beta unsaturated aldehyde. While in aldol reaction we get the product aldol. In aldol condensation we get the alpha beta unsaturated aldehyde. I repeat again, in aldol reaction, we get the aldol as a product. In aldol condensation, we get the carbon-carbon double bond, that is the alpha beta unsaturated aldehyde. Aldol condensation is not only undergo the basic conditions, but sometimes it is also undergo into the acidic condition. See, in reaction mechanism, when the aldehyde having the alpha hydrogen get protonated, after the protonation this carbon get more electropositive, that can be attacked by the enol form of another aldehyde and get the intermediate like this. By the removal of this hydrogen we get the simply aldol, and this aldol by the removal of water molecule give the condensed product, that is the alpha beta unsaturated aldehydes. See, this image can be clearly shows the what is the difference between the aldol condensation and aldol reaction. From the aldehyde we get the alpha beta hydroxy ketone, that is the aldol reaction, and from the aldehyde in presence of basic conditions via the formation of aldol we get the alpha beta unsaturated ketone, also called as enol, that is nothing but the aldol condensation. These are the different types of aldol cross aldol reaction. What is cross aldol reaction? That is nothing but the when the similar aldehydes are there, it is a simple aldol condensation. But suppose that the two different aldehydes are there, like propanaldehyde and acetaldehyde react with each other, then there may be the formation of different types of products, is known as cross aldol condensation. These are the few references I have referred. Uh, Claydon, Organic Chemistry by Morrison Boyd, and Organic Reaction Mechanism by B.K. Ogoya. The three books you can refer for the basic name reactions. Thank you for watching this video. We will see in the next part for the next reaction. Thank you.